Today we've got a really short lesson in periodic trends. So what periodic trends are basically things that you can look at and determine on the periodic table. So you already know a few periodic trends, like you know that the column number can help you determine the number of valence electrons, like it goes from 1 to 8 valence electrons as you move from left to right across the periodic table. You also know how to determine charge by looking at the periodic table. We've talked so far about different names of different groups on the periodic table. So like group 1 is the alkali metals, group 2 is the alkaline earth metals. We've got the halogens in the group 7 and then the noble gases in group 8. Remember, groups or families are the columns, periods are the rows. We know that the non-metals live on the right side of the periodic table, and the metals live on the left side of the periodic table. And then we've got that stair step of metalloids that exist and kind of behave similar to metals and non-metals. Well, today we're going to start by talking about atomic size. And so atomic size is determined by a technique called X-ray diffraction, where they use X-rays to be able to shine light and be able to measure what is known as the atomic radius. So you know the radius from math. The radius is the distance from the edge. Now some elements, like diatomic elements that don't exist as a single atom, they have to measure the distance between two atoms because they don't exist as a single atom, and then divide that in half. And that's the atomic radius that you see there. And so when we look at the periodic table, atomic radius increases down and to the left, okay? Down and to the left. So those elements in group 1A, specifically those at the bottom, are going to have the largest atomic radius, okay? Down and to the left. So this periodic table, it's a abbreviated one. Cesium is the biggest, but actually francium, if you go down to the next row, is kind of the biggest, or is the biggest, not kind of. Now these trends do not include that lanthanide and actinide series, which are those two offset rows at the very bottom of the periodic table. These just include, those in the main part of the periodic table, okay? So this is just a graph of the atomic number, of the atomic radius, and so you see those that are the biggest are lithium, sodium, potassium, all of those alkali earth metals in that periodic table. And there's that francium that I just mentioned that is the biggest, okay? And so, and then, it works its way up and drops it back down. And that's what you see for a lot of the periodic trends, okay? And so, lithium is the smallest of the alkali metals because it's the one at the top. It's the one in the first row or first period. Francium is the biggest because it's the one at the bottom. So that trend increases as we go down and to the left. So the next trend we're going to talk about is ionization energy. So ionization energy is the energy required to remove an electron. What's that called when you remove an electron? What does it become? It becomes an ion, right? If you gain an electron or lose an electron, it becomes an ion. So this specifically says remove an electron. So if something loses an electron, it's an anion. It's a cation. Okay, did I say that right? Cation's positive, yeah, and it has lost an electron. If something gains an electron, it is an anion, which is negative, okay? So ionization energy describes the energy required to take an electron away. So remember, all atoms want to have 8 valence electrons. That's the goal, right? And those noble gases in the very last column have 8 valence electrons. So they're going to have the highest ionization energy. They are not going to let anybody steal their electrons, okay? The next biggest one are going to be those those halogens beside them, they have 7 valence electrons. And so they also don't want anybody to steal their electrons. Versus if we look at the first column, those alkali metals, they have 1 valence electron. And so they're more apt to give up that 1 valence electron. Because remember, if they give it up, it takes them back to having a complete octet in the circle before that circle. Okay? And so that is ionization energy. So first ionization energy describes how much energy it takes to steal 1 electron. So those alkali metals, they're going to have a pretty low first ionization energy because they'll easily give away 1 electron because that would get them back to a full octet. Okay? Now, if you look at the second ionization energy, that's the energy it requires to take a second electron. So if we're talking about those alkali metals in that first column again, they'll let you take 1 from them because that'll take them back to having a full octet. But they're not going to let you take 2 electrons from them because that second one is going to pull from that octet that they really want to keep. Okay? So we're just looking at ionization energy in general. And so it increases as you move from left to right. But I do want you to understand the difference in what we mean by first, second, third ionization energy would be the energy that requires to take 3 electrons, and so on and so forth. So increases as you move from left to right. So we're getting to the right. Those are going to be the guys that have more valence electrons and less likely to give them up. Okay? And so what we see here is these have the most ionization energy. And those are those noble gases. Those are the ones that have the full octet that don't want to give up those electrons. These are the ones that have the lowest first ionization energy. And you should recognize those as the alkali metals in that first column. And they're happy to give up 1 valence electron, okay? Because that takes them back, as we just said, to the full octet. All right, periodic trends. So, cations, as we just mentioned, cations are the positive ones. Remember, they have lost an electron. Anions are the negative ones. They have gained an electron, okay? So, one thing that it's important to know is cations are always smaller than the neutral atoms from which they form. So, that makes sense, okay? If you lose something, you're going to be a little bit smaller. Now, remember, it does make sense because you lose, you're going to be smaller. But electrons are so teeny, 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 tiny. They have such a negligible mass and size. So don't think of it as, don't misunderstand your idea of an electron if you use that to help you remember it, okay? But then on the flip side, if you gain something, generally you're going to be larger, okay? If I gain weight, I'm going to be larger. So cations are smaller than the neutral atom. So let's take a look at lithium, okay? Lithium, this gray is going to be the neutral atom. This green is going to be the cation. That cation is much smaller than the neutral atom. And the same thing is true for all of these. The cation, the green, is much smaller than the neutral atom, which is the gray. And so we see these group 1 and group 2. Those are the ones that typically form cations. All right? If we move over here on our modified periodic table to group 16 or 17, 13, sorry, that should be with the cations. To group 16 or 17, okay, these are our halogens in group 17. So anions are always larger than the neutral atoms from which they form. So the purple is the anion, that's the F minus, and then the gray is the F. So the gray for both of them is the neutral atom, okay? The colored one is the ion. And so you see here, the ion is much bigger than the neutral atom, okay? So that's an important trend to remember as well. And those sizes generally increase as you go down the periodic table. All right, let's look at the next trend. The next trend is electronegativity. And what electronegativity is the ability of an atom to steal electrons, okay? It has an affinity or ability to attract electrons. And so the element with the highest electronegativity is going to be fluorine. Electronegativity increases as you move up and to the right, increases up and to the right, or this says decreases down and to the left, okay? So either way you want to think of that. Electronegativity is how hard it's going to try to steal those electrons. In some elements, electrons are shared equally, okay? In other elements, the electrons are going to be pulled more to one element than to the other, okay? And so you can actually assign elements an electronegativity number. And there's special periodic tables that do this. And so you see here those with the dark red, which there's only one. There's that fluorine I just told you about, okay? And then in the light red, we have the oxygen, nitrogen, and chlorine. So those are by far the highest, the most electronegative elements. If you take AP Biology with me next year, we talk a lot about electronegativity. That's a really important concept there. But we refer to the electronegative elements as the FONs, F-O-N. Now, chlorine is still one. We just leave it out because chlorine is not a very biological element, meaning you don't have a lot of chlorine in your body or in living systems, versus you do have large amounts of nitrogen and oxygen. Not so much fluorine, but we just throw fluorine in there because he's such an electronegative element, okay? So electronegativity will continue to be important in biology, but it's how they steal electrons, okay? So this table just summarizes the trend. Atomic radius decreases to the right. Atomic radius increases as you go down, and you can read those. Please go back and draw these trends in on your periodic table. You have a bit of an advantage this year since you're virtual. Normally when I give this test in class, I would give you a fresh periodic table, and I wouldn't allow you to use your periodic table where you've drawn in your trends. Although I do encourage you to do that because I hope that you will keep this periodic table. That is like my greatest hope. If you could pull this periodic table out when you go to college in the event that you take chemistry, you're going to have yourself a lot of help if you've kind of written a few little helpful notes along the way and, like frame it, and it would just like make my day. So, but for now, go ahead and write those trends because it'll help you as we go on and with your assignment today. So you have a brief assignment on Google Classroom today. Go ahead and complete that. And if you have any questions, then let me know. And if not, then you'll have a great day.